Namaste students. Before going to the next topic, displacement reaction, I want to discuss in text problem, in text problems of page number 10 NCRT questions which is based on previous lecture. Then after we will discuss about displacement reaction. So first question of page number 10 is a solution of a substance X is used for whitewashing. Name the substance X and write its formula. Dear students, for whitewashing we use quicklime. Name the substance quicklime. It is common name, and a chemical name for this substance is calcium oxide, and its chemical formula CaO. Then question number 2, write the reaction of the substance X named in above with water. So X is quicklime, that is CaO, and it reacts with water CaO in the form of solid, it reacts with water in the form of liquid. It forms calcium hydroxide, also known as slacked lime. This question is based on combination reaction. Question number 2, why is the amount of gas collected in one of the test tube in activity 1.7? Activity 1.7 is given in NCRT book, and it is an example of electrolytic decomposition. Electrolytic decomposition, in which electrolysis of water is given. So question is that activity 1.7 double of the amount collected in the other. Name this gas. In activity 1.7, electrolysis of water decomposes in the presence of electric current. It gives hydrogen gas as well as oxygen gas. For after balancing we use 2 as a coefficient in H2O, and for hydrogen 2, then after it is balanced. So in this question you have to tell about why is the amount of one gases double from other. We see in this chemical equation the amount of hydrogen gas is double in comparison to oxygen, because the ratio of atoms present in a molecule of water is 2:1. That's why amount of hydrogen gas is doubled in comparison to oxygen, because the ratio of atoms present in a one molecule of water 2:1. That's why it is double of the amount of the collected in the other. And name this gas is hydrogen. That's all. Now we will start next topic, that is next type of chemical reaction, displacement reaction. Displacement reaction in which a more reactive element displaces a less reactive element. Reaction in which a more reactive element displaces a less reactive element is known as displacement reaction. Dear students, as we know that element mainly divided into two parts, metal and non-metal. And in above chemical reaction, that is displacement reaction, we know that a more reactive element displaces a less reactive element. So this displacement reaction categorized into two parts. One is metal displacement reaction, and second one is non-metal displacement reaction. In chapter 1, we discuss mainly about metal displacement reaction, in which a more reactive metal displaces a less reactive metal. Then question is that how can we say that a particular metal is more reactive or less reactive? So before going to the point, we write examples of metal displacement. When copper sulfate aqueous solution, its color is blue. When iron in the form of solid added into in aqueous solution of copper sulfate whose color is blue. It decolorizes the color of blue and convert it to light green ferrous sulfate aqueous and form copper in the form of solid. In this reaction, we see that this iron displaces copper to form new substance iron sulfate and copper removed from the solution. So in this chemical reaction, that is displacement reaction, metal displacement reaction, we see that iron displaces copper. That's why iron is more reactive than copper. Other example, zinc react with copper sulfate. It also forms in the form of solid CuSO4 in the form of aqueous. It gives ZnSO4 aqueous plus Cu in the form of solid. In this chemical reaction, we also see that zinc displaces copper. That's why it forms zinc sulfate and copper in the form of solid. So dear students, how can we confirm that this metal is more reactive or less reactive? Suppose that we take other example in ZnSO4 aqueous, we add copper into the solution. We see that copper does not displaces zinc, and that's why displacement not possible. Other example, ZnSO4 aqueous, when lead is added into the solution, displacement is also not take place. That's why we need a series by which we can know that whose element, that is metal, is more reactive or less reactive. In reactivity series, a series by which we can say that this metal is more reactive or less reactive. So for better understanding the metal displacement reaction, we have to know about the reactivity series of the metals. So a reactivity series of metals which will be discussed in chapter 3, metals and nonmetals. So here we also know about reactivity series. Reactivity series, a series in which metals are arranged in their decreasing order or increasing order. A series in which metals are arranged in their decreasing order or increasing order, that series is known as reactivity series. This series potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. In this series, we see that potassium is the most reactive, while platinum is least reactive. When we move from platinum to potassium, reactivity increases, and we move from potassium to platinum, reactivity decreases. On the basis of this chart, we can confirm that displacement is possible or not possible. So let us example for better understanding. We take iron sulfate aqueous and we add into zinc in the form of solid. What will be happen? In this series, we see that FeSO4 aqueous is taken in a test tube and we add zinc in the form of solid. With the help of reactivity series, we see here iron and here zinc. It is above from iron and we move downward to upward, reactivity increases. That means zinc is more reactive than iron, so displacement is possible and it forms new substance ZnSO4 aqueous plus iron displaces into solution in the form of solid. Next example, we take ZnSO4 aqueous and we add tin in the form of solution in the form of solid state. We see that in this example here is zinc and tin is here, so zinc and tin, zinc is above than tin. That means tin is less reactive than zinc, so displacement is not possible. So here no product will be formed. So dear students, we have learned about displacement reaction and especially for metal displacement. So dear students, prepare notes and solve problem based on this topic. Thank you.